Hello. There are many techniques for solving quadratic equations. Factoring, graphing, and completing the square are some of the most common. However, there is also a generic formula that can be used to solve a quadratic equation in standard form. When using the complete the square technique on the standard form quadratic, the values for x in terms of a, b, and c are as follows. The opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a, will give us our x values. This is an example of that derivation. Read carefully through this process if you are interested. This is known as the quadratic formula and can be used on any quadratic in standard form when the a, b, and c values are identified. For example, when rewritten as a standard trinomial equal to 0, the a value in this problem is 2, b is -1, and c is -4. Now, by substituting into the formula and simplifying, we see the following. So, without factoring, graphing, or completing the square, we have two solutions for the quadratic. Let's try another. After rewriting in standard form, the a value in this problem is 1, b is 4, and c is 3. By substituting into the formula and simplifying, we see the following. Again, without factoring, graphing, or completing the square, we have two solutions for this quadratic. What was interesting about these solutions is that both are nice integer answers that could have been obtained by factoring, but the quadratic formula offers an alternative that works in any case. The computation inside the radical is known as the discriminant. This is sometimes determined first because the value of the discriminant helps us to understand the nature of the solutions to the quadratic of the equation. When the discriminant is positive, there will be two real number solutions. When the discriminant is 0, there will be one real number solution. And when the discriminant is negative, there will be no real number solutions. Instead, there will be two complex number solutions. But why are these statements true? Well, if you think about it, one must find the square root of the discriminant inside the quadratic formula. And the square root of a positive number has two real number solutions. The square root of 0 has just one solution, whereas the square root of a negative number has no real solutions, but two imaginary number solutions. We can consider the quadratic formula written this way when computing the discriminant first. In these examples, I would like to determine the discriminant and the nature of the roots first, then solve for x. I like to write down the values for a, b, and c, then compute d. Since the discriminant is positive, I know we will have two real number solutions. We can now identify them very quickly. If needed, we would compute the decimal equivalents at this point. Please pause the video now and try the last two examples on your own. Resume playback in a moment to check your work. Good luck.